We've been given a g of x function of negative 3x cubed plus 2x squared minus 3x plus 5. Okay, and that's what the picture looks like on the axis. We then have been given a tangent. Can you see there's a tangent to the graph over there? And the point of tangency where it's touching at the one spot is this point over here, which is where it's just touching at one point, okay? That's a point of tangency, and just so we are clear, that's a point of intersection where the two graphs are actually crossing each other, okay? What is the equation of a straight line graph? Okay, the tangent being the straight line graph. So the equation of a straight line graph is y equals mx plus c, or ax plus q, or bx, whatever the variables are that you've used, it needs to be in that format over there. And we know, we said in the previous video, that the gradient of the tangent, so the gradient of this yellow line, equals the derivative. Okay, so the derivative, in fact it's going to be g of x, the derivative is equal to the m value, right? It's equal to the gradient of your tangent. Okay, now I'm writing that down there just so that I kind of have it in my head, and we will use it, no doubt, as we're going along. Okay. Let's take those out for a minute here. We've been asked to determine the equation of the tangent at the point where x is equal to negative 1. Okay, that's important because they're telling me the point of the x coordinate at the point of tangency. So we know that it's negative 1 at that point over there. If I know that it's negative 1, do you agree with me, we're able to work out the y value. How? By substituting negative 1 into the x's, into each x value of my g of x equation, all right? That works out to be 13. So the y coordinate that we're missing at that point of contact is 13, okay? How's that going to help me now? So we've got the point of contact. We need to work with this. The derivative equals the gradient of your tangent. What's the derivative of this f of x, of this g of x function here? The derivative would be as follows. It would be g prime x is equal to negative 9x squared plus 4x minus 3. Okay, now we know that the x value at the point of contact, or the point of tangency, is negative 1. So we're going to substitute the x value with negative 1, okay? And that, when I substitute my negative 1 into my derivative, we're getting negative 16. So that is your gradient, okay? So I now know this. I know that the equation of the tangent is y is equal to negative 16x plus c. We have to find my value for c. How are we going to do it? We use the point of contact, the point that it's touching. Y gets substituted with 13, x gets substituted with negative 1, and we solve for c. And we land up with negative 3 as the value for c. All right, I haven't shown all that working out, but I would like you to obviously go ahead and do all of that so that you are with me. And it's negative 16x minus 3. Okay, and that's the equation of the tangent that they were looking for. It then asks us to find the coordinates where the point where the tangent and the curve cut again. So as I mentioned earlier, where they cut again is that point over there, that point of intersection. Now this is really just normal graph knowledge. A point of intersection is where the two lines are actually equal to each other. All right. So how are we working out the coordinates of that point? We are making the equation of the two lines equal to each other. So we're going to take the equation of the tangent and we are making it equal to the cubic graph. Cube plus 2x squared. 2x squared minus 3x plus 5. Okay, and that's going to land up giving us, when we move everything over, we're going to land up with 3x cubed minus 2x squared minus 13x and minus 8 being equal to 0. Obviously, it does involve a whole story of factoring this again, okay? I remember trial and error. You substitute something into x until you get your value of 0. Once you've got that, then you need to do synthetic division or long division and work out how many times it goes in. You need to follow that process, but this is what you need to get to. You need to have three brackets of an x plus 1. You have a 3x minus 8, and you have an x plus 1, okay? Which means that -1, 8 over 3, and -1 again. We already knew -1. -1 we already knew was the one point where the graphs touched each other. So obviously 8 over 3 is the other x coordinate. And then once we know that, we need to substitute the x value back into either the cubic or the tangent equation, either one, to get the y value, which is giving us -45 2/3. Okay, and that then is the other point of intersection of the two graphs. Alrighty, good. I've got another example for you, so please make sure you try it. See you now.